Let us see the exercise problems. Exercise 1.1. First question. Using appropriate properties, find these values. Let us see the first problem. Here, negative 2 by 3 times 3 by 5 plus 5 by 2 minus 3 by 5 times 1 by 6. If you observe, here we have 3 by 5 and here also we have 3 by 5. So we can make use of these two. For that, we need to regroup these two values. So first, this is equal to, let us write negative 2 by 3 times 3 by 5. 5 by 2 minus this one. Let us write this one as minus 3 by 5 times 1 by 6, then plus 5 by 2. How we wrote this? By regrouping. This is equal to negative 2 by 3 times 3 by 5 minus, use commutative property under multiplication. We can write 3 by 5 times 1 by 6 as 1 by 6 times 3 by 5 plus 5 by 2. Now if you observe these values, here 3 by 5 and 3 by 5 we have. We can take common. That means we can use distributive property. This is equal to, we can write like this, times 3 by 5. If you take 3 by 5 as common, so 3 by 5 has gone to common. Now the remaining values are negative 2 by 3 minus 1 by 6, then plus 5 by 2. So this is equal to, within the brackets let us simplify those values. Negative 2 by 3. In the second term we have 6 in the denominator. So let us make the denominators equal. For that, let us multiply both numerator and denominator with 2. So we can write 2 by 2. Then minus 1 by 6 times 3 by 5 plus 5 by 2. So this is equal to, this is negative 4 by 6 minus 1 by 6 times 3 by 5 plus 5 by 2. Now this is equal to, within the brackets we have 6, that is in the denominator, that is common to both. So we can take 6 as LCM and write 6 as the common denominator. So in the numerator we have minus 4 and minus 1, then times 3 by 5 plus 5 by 2. So this becomes minus 4 minus 1 means minus 5 divided by 6, then times 3 by 5, then plus 5 by 2. This is equal to, we can cross out 5 and 5 and 3 times 1 and this is 3 times 2. So this is equal to minus 1 by 2 plus 5 by 2. This is equal to, take 2 as the common denominator, that is LCM. So in the numerator we will get minus 1 plus 5. So this is equal to minus 1 plus 5 means 4 by 2, which is equal to 2. So this is the answer. Let us do the second question. Here if we observe 2 by 5 and here we have 2 by 5. So those are common. This is equal to, let us write this one as 2 by 5 times minus 3 by 7. Then regroup. So first write this term before this term. So we can write like this, plus 1 by 14 times 2 by 5. Then write the next term, that is minus 1 by 6 times 3 by 2. So this is equal to 2 by 5 times minus 3 by 7. Then use commutative property under multiplication. So we can write this one as plus 2 by 5 times 1 by 14, then minus 1 by 6 times 3 by 2. So this is equal to, now take 2 by 5 as common. So that means use distributive property. Within the brackets we will get the remaining terms, minus 3 by 7 and 1 by 14. So this is minus 3 by 7 plus 1 by 14. Then minus, here if you observe we can cross out actually 3 times 1 and this is 3 times 2. So this is equal to, in the numerator minus 1 times 1 is 1 by 2 times 2, that is in the denominator 2 times 2 is 4. So this is equal to 2 by 5 times minus 3 by 7. As in the second term we have 14 in the denominator, let us multiply both numerator and denominator by 2, so that we will get 14 in the denominator for the first term also within the brackets. So plus 1 by 14 minus 1 by 4. This is equal to 2 by 5 times this is minus 6 by 14. 3 times 2 is 6. So 6 by 14 minus 6 by 14 plus 1 by 14, then minus 1 by 4. Now this is equal to 2 by 5 times, here 14 is the common denominator, we can write 14 like this, and then in the numerator minus 6 plus 1, then minus 1 by 4. So this is equal to 2 by 5 times this is minus 6 plus 1 means minus 5 divided by 14 minus 1 by 4. So 5 and 5 cross out, then 2 times 1 and this is 2 times 7. So this is equal to minus 1 by 7 minus 1 by 4. So this is equal to, we can take for the denominators are 7 and 4. We can take the LCM, that is 7 times 4 is 28 is the LCM. 7 divides 28 4 times. So 4 into the numerator is negative 1. So minus 4 minus, in the second term we have 4 in the denominator. 4 times 7 is 28. So that 7 into the numerator 1. So 7, which is equal to negative 11 by 28. This is the answer. Let's go to the next problem. Write the additive inverse of each of the following. We know that if you take A as the number, the additive inverse of this number is negative A. So for the first problem, 2 by 8 we have, the additive inverse will be negative 2 by 8. This is for the first one. Now second problem, negative 5 by 9. For this additive inverse equal to, change the sign, that means minus of minus 5 by 9. This is what we need to write. This is equal to minus of minus means plus 5 by 9. That is the additive inverse of negative 5 by 9. Let us take the third one. Third one is negative 6 by negative 5. Actually this is equal to minus and minus we can cancel, 6 by 5. For this the additive inverse is simply negative 6 by 5. Next, for fourth problem we have 2 by negative 9. This can be written as negative 2 by 9. For this the additive inverse will be equal to, we need to write minus A, that means minus of minus 2 by 9, which is equal to 2 by 9. Next, for the fifth one we have 19 by minus 6. We can write this one as minus 19 by 6. So additive inverse equal to minus of minus 19 by 6, which is equal to 19 by 6. Let us go to the next question. Verify that minus of minus x equal to x. So first let us take first one. Given that x equal to 11 by 15. First let us find out minus x, which is equal to minus 11 by 15. Then minus of minus x equal to minus of minus 11 by 15. Minus of minus means plus. So this is equal to 11 by 15. 11 by 15, that is actually the value of x. So we can write this is equal to x. So we can conclude minus of minus x equal to x in this case. Now let us do the second problem. Here given that x equal to negative 13 by 17. Now let us find out minus x. That is equal to, minus x means minus, x is minus 13 by 17. Here in this case minus of minus means plus. So plus 13 by 17. This is minus x value. Now minus of minus x, which is equal to minus, be careful here, minus x value here is 13 by 17. So this is the value of minus x. So instead of this minus x here, let us write here 13 by 17. So minus 13 by 17. So actually minus 13 by 17, this is equal to x value. So this is equal to x. So we can conclude that minus of minus x equal to x. Let us go to the next problem. Find the multiplicative inverse of the following. We know that multiplicative inverse, or we can call this one as reciprocal also, of a number a is equal to 1 by a. We know this. So here let us take the first one. Given number is negative 13. So multiplicative inverse of this negative 13 equal to, as we know that multiplicative inverse of a is 1 by a, we can write the multiplicative inverse of negative 13 as 1 by negative 13, which is equal to negative 1 by 13. Second problem, negative 13 by 19. So for this multiplicative inverse equal to, actually we need to write 1 by this value, but instead of doing that, simply flip this numerator and denominator. That means write numerator as denominator and denominator as numerator. So this becomes 19 by negative 13. This is equal to minus 19 by 13. Next, third one, 1 by 5. For this, the multiplicative inverse is simply 5. Next, let us take fourth one. Minus 5 by 8 times minus 3 by 7 we have. First, let us find out the value of this one. Let us multiply numerators and denominators separately. Minus 5 times minus 3 means plus 5 into 3, 15, divided by 8 times 7 is 56. So therefore multiplicative inverse equal to, simply write this one as 56 by 15. Next, fifth question. Minus 1 times minus 2 by 5. First let us find out the value of this one. Minus 1 times minus 2 is minus into minus, plus 1 into 2 is 2. So 2 by 5. For this multiplicative inverse equal to, for 2 by 5 multiplicative inverse is 5 by 2. For sixth one, minus 1 we have. Multiplicative inverse equal to 1 by a. So that means 1 by minus 1, which is equal to again minus 1. Name the property under multiplication used in each of the following. In the first one you see, you observe that is like a times 1 equal to 1 times a equal to a. Instead of a we have negative 4 by 5 here. This is multiplicative identity. In the second one you see here, suppose if you take this one as a and this one as b, then clearly this is like a times b equal to b times a. This is nothing but commutative property under multiplication. Let us take the third problem. Negative 19 by 29 times 29 by negative 19 equal to 1. So this looks like a times 1 by a equal to 1. So this is clearly, this is multiplicative inverse property. Okay, let's go to the next question. Sixth problem, if we see, multiply 6 by 13 by reciprocal of negative 7 by 16. First let us write reciprocal of negative 7 by 16 equal to, reciprocal means this is nothing but multiplicative inverse. So we can write this one as 16 by negative 7, or we can write or we can write this one as negative 16 by 7. Now multiply 6 by 13 with reciprocal of this one. So 6 by 13 times negative 16 by 7. This is what we need to find out. This is equal to 6 times 16 is 96. We have minus symbol, so write minus, divided by 13 times 7 is 91. So this is the answer. Next, let us go to the 7th problem. Tell what property allows you to compute this one. 1 by 3 times 6 times 4 by 3 as 1 by 3 times 6 times 4 by 3. If you observe, this looks like A times B times C. This is equal to A times B times C. This is clearly associative property under multiplication. This is nothing but associative property under multiplication. Let's go to the next problem. Let us see 8th problem. Is 8 by 9 the multiplicative inverse of negative 1 over 8? Why or why not? So here first let us simplify minus 1 by 8. This is equal to, this is a mixed fraction, write this as improper fraction. So 8 times 1 is 8, then plus 1 9. So minus 9 by 8. The multiplicative inverse of negative 9 by 8 is, this is negative 8 by 9 actually. But given that 8 by 9 we have, 8 by 9 is not the multiplicative inverse of this one. Minus 8 by 9 is the multiplicative inverse. Therefore, we can write 8 by 9 is not multiplicative inverse of minus 1 by 8. So let us go to the 9th problem. This is very much similar to the previous problem. Is 0.3 the multiplicative inverse of 3 1/3? First let us find out the value of 3 1 by 3. This is equal to, let us convert this into improper fraction. 3 times 3 is 9 plus 1 means 10. So 10 by 3. Now let us take 0.3. Let us convert this one into fractional form. This is equal to, whenever we are converting a decimal number into fractional form, first ignore the decimal point and write all the digits involved in that number. So clearly 0 and 3. So we can write 3 divided by, put 1. Then after the decimal point, how many digits we have? Let us count just only one digit. So put just 1 0. Now we need to check, is 3 by 10 is multiplicative inverse of 10 by 3 or not? Let us multiply these two so that we will get 1 or not. Let us check. So 3 by 10 times 10 by 3. Clearly we can cancel 3 times 1 and here also 3 times 1, 10 times 1 and 10 times 1, which is equal to 1 times 1 is 1 divided by 1, which is equal to 1. So we can say that 3 by 10 is a multiplicative inverse of 10 by 3. So that 0.3 is the multiplicative inverse of 3 1/3. So that is correct. Next, let us go to the 10th question and 11th question. So write the rational number that does not have reciprocal. What is the rational number that does not have reciprocal? 0. Why? Because the reciprocal of 0 is 1 by 0, which is undefined. The rational numbers that are equal to their reciprocals. Rational numbers. So that means we have more than 1. Clearly 1 and negative 1. These are the rational numbers that are their own reciprocals. For 1, the reciprocal is 1 by 1, which is equal to 1. So 1 is reciprocal of itself. Similarly, for negative 1, 1 by negative 1, which is equal to negative 1. Here also negative 1 is the reciprocal of negative 1 itself. So we can say that 1 and negative 1 are the rational numbers that are equal to their reciprocals. Let us see the third one. The rational number that is equal to its negative. That means if you understand the question carefully, the rational number that is equal to its negative. That means if you write negative to any number, that negative symbol should not affect the number. So we need to think about that number. 0 is the only such type of number. So the answer for this one is 0. For the first one, the answer is 0. For the second one, the answer is 1 and negative 1. For the third one, 0. Now you see here, fill in the blanks. 0 has dash reciprocal. Actually, no reciprocal. Second problem. The numbers dash and dash are their own reciprocals. Clearly 1 and negative 1 as we discussed in previous problem. Then third one. The reciprocal of negative 5 is, we know that, negative 1 by 5. Fourth problem. Reciprocal of 1 by x is simply x. Fifth problem. The product of two rational numbers is always a. The product of two rational numbers is always again a rational number. So the answer is rational number. The reciprocal of a positive rational number is, again it's a positive rational number. That is the answer. So these are the answers for the problems in exercise 1. Thank you. Thank you for watching. Please subscribe my channel.